Have you ever been genuinely surprised by something an AI said? Like, it gave you an answer that made you stop and just think, wow, okay, that was actually pretty clever. You're definitely not alone if you have.
Yeah.
It really feels like these large language models, LLMs, are constantly leveling up.
Yeah, that feeling of surprise, it really gets right to the core of what we're digging into today.
Oh,
This deep dive is all about this fascinating and honestly really fast-moving world of LLM reasoning.
mm,
These models, they can do some truly impressive things, no doubt.
yeah.
But how they actually think,
Yeah.
well, whether it's real reasoning or maybe something else entirely, that's a huge question researchers are grappling with right now.
Exactly. And we've pulled together some really interesting recent research to try and get a handle on this. We're looking at a broad overview from Sun and colleagues from last year
Mhm.
about how these foundation models reason. And then we've got work from Kiao et al., also 2023, which really breaks down the different techniques people are using to try and get LLMs to, well, reason better.
Hmm.
Huang and colleagues, again from 2023, offer another perspective on these methods. And then to really, stir the pot a bit, we've got this very thought-provoking paper from Kamapati from this year that kind of challenges some assumptions about what's actually going on under the hood.
Right. And these different pieces, they give us a pretty well-rounded picture, I think, of the current state of play. They show not just what LLMs can do, but the different ways people are trying to push them. And crucially, some of these really fundamental questions about whether it's the same kind of thinking that we do as humans.
Yeah.
So our goal today is basically to pull out the most insightful nuggets from this research, give you a clear sense of the key debates around LLM reasoning without getting totally lost in the weeds.
Yeah, like the quick guide to the state of LLM reasoning.
Exactly. Consider it the cheat sheet to understanding this really cutting-edge area.
Okay, so let's jump in. When we talk about LLM reasoning, what what are we actually talking about? I mean, we see these things writing code, answering really complex questions. Sometimes they even seem to get nuance. That feels like it's got to be more than just like spitting backstored information, doesn't it?
It absolutely feels that way.
Yeah.
LLMs have made just incredible strides. I mean, a huge range of tasks. And when we talk about reasoning, generally, we mean the ability to think logically, right? To
Mm.
make connections, solve problems, understand cause and effect is pretty fundamental to what we consider intelligence. So naturally, there's a huge focus in AI research on both understanding and improving this capability in machines.
So when Sun and their team looked at this last year, what were some of the key types, maybe, of reasoning they were seeing or looking for in these advanced AI systems?
Yeah, their overview takes a really wide lens, which is interesting. It looks beyond just the text models we usually think of. It includes things like multimodal models, AI that can handle different kinds of information like text and images together,
Mm.
and even autonomous language agents, things that could potentially interact with the world. What's fascinating is they point out that reasoning isn't just this one monolithic thing. They break it down. They talk about mathematical reasoning, tackling equations, proofs, logical reasoning deductions, inferences, causal reasoning, figuring out why things happen, and even visual reasoning, which is about interpreting what's actually in an image, making sense of it. Their work really paints a picture of all the different sort of flavors of reasoning we're hoping these AI systems can eventually master.
That's a really useful breakdown. Different flavors. Okay, so we have these different types of reasoning. Now, how do researchers actually try to get LLMs to do these things? Is it just about asking the perfect question, or is there more to it?
Well, asking the right question, what gets called prompt engineering, is definitely a huge piece of the puzzle, a really big piece. But yeah, there's more. That 2023 paper by Kiao and colleagues really digs into the different strategies. They sort of group them broadly into what they call reasoning enhanced strategies and then knowledge enhancement reasoning.
Okay, reasoning enhanced strategies.
Just
That sounds like the more direct approach, maybe. What does that involve?
exactly. According to Kiao et al., this covers prompt engineering itself, like carefully crafting the input to guide the model's thinking process. But also things like process optimization. That can mean breaking down a complex problem into smaller steps, making it more manageable for the AI, and even using external tools or like knowledge databases to help the LLM out during its reasoning process.
Okay, so sticking with prompt engineering for a second,
Mm.
what are some specific tricks or, techniques people are finding effective?
Yeah, Kiao et al., I highlight some really interesting ones. They're these single-stage prompting strategies. Probably the most famous one is chain of thought.
Mm.
Think of it like asking the AI to show its work like you would in a math class
Huh?
by encouraging it, prompting it, to actually explain its reasoning step by step, you often get much, much better results on complex tasks. It's quite remarkable. Another one they mentioned is active prompt, where the model itself might try to ask clarifying questions or seek out more information to improve its own reasoning, sort of turning the tables.
Interesting. And Huang's paper mentions similar things.
Yes, Huang et al. Huang's work also really emphasizes the importance of these prompting methods. They talk about chain of thought, too, but also things like problem decomposition,
Yeah.
breaking a big problem down, and also in-context learning. That's where you basically give the model a few examples of how to reason through a similar problem right there in the prompt itself. Show, don't just tell.
Okay, so it sounds like a lot of getting LLMs to reason effectively really comes down to how clever we are at designing the prompts, at guiding them. But, I mean, this brings up the really big question, doesn't it? Are these models actually reasoning, genuinely thinking, or are they just becoming incredibly, incredibly good at imitating reasoning based on, the mountains of text they've ingested?
That is the million-dollar question, right? Maybe the billion-dollar question. And it's the one that Kamapati really tackles head-on in his paper from this year. He makes a really compelling, though perhaps controversial, argument. He argues that while LLMs can certainly produce outputs that look an awful lot like reasoning and planning, they might not be doing it in the same way we do, not with, genuine understanding or manipulation of abstract concepts.
Oh, right. This is where it gets really interesting, I think. What's the core of his argument? Why does he think that?
So his main point is that current LLMs might not be truly reasoning or planning in the sense that we traditionally understand those words, having a deep grasp of the world, forming intentions, pursuing goals through logical steps. Instead, he proposes that their impressive abilities might actually stem from something else. He calls it universal approximate retrieval.
Universal approximate retrieval. Okay, that sounds pretty technical. Can you break that down for us a bit?
Yeah, let's try. Think of it like this. These models have been trained on just an unimaginably huge data set, right? Pretty much the entire internet and more. Because of that, they've become incredibly skilled at finding and stitching together bits of information, phrases, sentences, ideas that are statistically likely to follow from whatever input you give them. So when they seem to be reasoning like following logical steps, Kamapati suggests they might actually just be retrieving and assembling patterns they've seen countless times in their training data, connections that just happen to look like logic. It's less about understanding the why of the logic and more about knowing what typically comes next in sequences of text that involve similar concepts. He argues this super advanced form of pattern matching, this retrieval, can often look almost identical to reasoning from the outside.
So it's like they're masters of finding the answers that look right based on everything they've ever read. But they don't necessarily understand why those answers are right on a deeper level.
That's a pretty good way to put it, yeah. Kamapati is careful, he presents it as his perspective. And it's definitely a hot topic, a very active debate in the field. But his idea forces us to really scrutinize what we mean when we say an AI is reasoning. If it's mostly just incredibly sophisticated retrieval and pattern matching, what does that imply about the AI's ability to handle truly novel situations, things it hasn't encountered patterns for in its training data? That's a key question.
Okay, wow. So let's try and pull this all together then for you listening. What are the key things we should take away from this deep dive into LLM reasoning?
Okay, well, firstly, it's clear that reasoning in LLMs is a really complex area, and it's evolving incredibly fast. We are seeing amazing progress in what these models can do. That's undeniable. Secondly, the way we interact with them, especially through prompt engineering, seems absolutely crucial right now. It's key for unlocking and maybe even enhancing whatever reasoning abilities they have. Techniques like chain of thought, asking them to show their work, are proving really effective in guiding their output generation process, let's say.
Right. And then there's the big kind of philosophical maybe question that's still very much up in the air. Is what we're seeing genuine reasoning, or is it this incredibly advanced form of pattern recognition and information retrieval, as Kamapati suggests?
Precisely. You've got these different schools of thought. And Kamapati's idea of universal approximate retrieval gives us a really powerful alternative framework for thinking about their capabilities. Ultimately, for you using or encountering these tools, understanding this distinction, or at least the debate around it, is pretty important for setting realistic expectations about what AI can and maybe more importantly cannot currently do. So when you see an AI give a really clever answer, you might ask yourself, Am I seeing genuine insight, or am I seeing the result of this incredibly powerful pattern matching machine we've been discussing?
Mm. Okay. So to wrap things up then, LLMs are getting seriously good at tasks that definitely look like reasoning. Smart prompting, clever interaction is a huge factor in making that happen. But there's still this fundamental question, this ongoing debate about whether they truly understand and reason like humans do, or if they're just exceptionally good mimics, finding patterns in their enormous data sets.
That sums it up really well, a concise and accurate summary. And, it leads to a final thought, maybe something provocative for you to consider. If LLMs are mostly performing this kind of universal approximate retrieval, what does that tell us about the nature of knowledge itself? And maybe about human understanding, too.
Yeah.
And thinking practically, how might we better leverage this unique capability, this super retrieval, even if it isn't reasoning in the way we traditionally thought about it?
Yeah, some really interesting questions to chew on there. Definitely food for thought. And if you are keen to explore this topic further, we definitely recommend checking out the research papers that sparked this discussion, the work by Sun, Kiao, Huang from last year, and that really interesting position paper by Kamapati from this year. This deep dive was really just intended as a starting point, an entry into what is a much larger and frankly incredibly fascinating conversation happening right now in AI.